We're a pretty informal group. Attendance is free. There's no formal membership list, and we normally do meet the second Thursday of each month except for December, when we don't have a meeting because of the holidays. So you can always join us for food and social at 6 p.m., and the meeting starts at 6:30. And in our normal meeting location, that's the Object Computing Incorporated training room at 12,140 Woodcrest Executive Drive, and that's Suite 310 in St. Louis. The bottom may have been cut off. It just says St. Louis.
Yep.
So I'd like to introduce the other members of the steering committee in addition to me. From left to right, we have Ted Doyle, Todd Zimmerman, me, Wei-Chi Gao, and Kathy Zwang. And so if you'd like to reach us on the steering committee, you can just send us an email and it will go to all of us at javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the support of our sponsors, so here's just a few. I'd like to thank OCI, Object Computing Incorporated. They provide our normal meeting room when we meet and the training room there. And they also pay for the web hosting for our website that we have in addition to Meetup. Edward Jones sponsors the subscription fees for the actual Meetup site. We also have food sponsors when we actually do meet in person. That includes Signature Consultants and Adaptive Solutions Group. They're recruiting firms, and they're always looking to hire developers. So if you're interested in a Java job, talk to the folks at Signature or Adaptive. When we meet in person, we normally raffle a JetBrains license. JetBrains is a sponsor of ours. We also raffle some gift cards from Elastic. They're the people who do Elasticsearch, if you've heard of that one. We also have a training company, Intertech, which has lots of online Java training. And they send us for the raffle the famous flying, screaming monkeys, where you stretch them and when they hit the wall, they scream. Well, they're a lot of fun. We also have ebooks from Manning and physical books from Pearson. So what we're going to do, we're just going to hold on to the raffle prizes and we'll just start raffling them again once we're able to meet in person. So that's what we're doing. Now, as far as upcoming presentations are going, we have Why Closure by Alex Miller on May 14th. Now, Alex is the organizer of another conference that meets in St. Louis called Strange Loop. I don't know if you've heard of that one, Jonathan.
No.
But yes, and they usually meet sometime in September.
Excellent.
Yes, and so I have been in contact with Alex, and he says he's willing to present from home if we're not able to do this online. We'll have to work out the platform and all of that. So if we need to do that online, we'll work out something here. On June 11th, we have Developing Low Latency Applications with Hazelcast. On July 9th, Migrating Beyond Java 8. On August 13th, we have Architecture Foundations, Styles, Patterns, and Trade-Offs by Neil Ford. So as I mentioned earlier, I went to DevNexus. That meeting was packed, and it was a huge auditorium. And so I made no bones about it when I went to that conference. I'm here to steal your speaker. And I managed to meet Neil Ford, and I stole him.
He's a good guy.
Yeah, and he's great, and he even said he's willing to fly to St. Louis, and I'm sure if we still have to be online, we'll work out something. We're going to get Neil Ford one way or the other. He's very good. I've seen his presentation. And then we've got Venkat Subramaniam. He makes the conference tours all the time, and he's back. He's been here before and gave an excellent presentation that just packed the house. This ain't your parents' Java. What we're talking about is new features that are coming in Java past Java 8, because I believe 14 just came out, and 15, I think, is available for testing. And so that's what's going on. So here's the bottom line. Watch meetup.com/gateway.jug for updates to the presentation schedule and the location if we have to move these presentations online. That way you'll know. As soon as we know something, we're going to put it out on Meetup. And it's okay to go ahead and RSVP, because then we can just send you an email with the latest as soon as it changes. Also, if you're interested in giving a presentation or becoming one of the JUG sponsors, you can just send us an email at that JavaSigSC email address. So that's about all I have here. People are probably impatient to actually hear the real reason why you're here. So tonight's presentation then is Understanding Kubernetes, Distilling Java Containers. So why don't I just hand it over to you, and I'll just let you talk. If you have questions, I believe you can type them in the chat window. And Jonathan, I believe you can see them.
Yes,
and we just had a little tutorial just a few minutes ago. I hope it'll work to see if we can answer questions as they come up. Right. So why don't you take it away, Jonathan? You can take control of the screen here. And thanks everybody for coming.
Yeah, and if we don't see your question, just shout louder. I don't know how you shout louder, but
yeah, just yell at the screen.
All caps, I guess, is fine too. We're all friends here. Well, Bruce, you have a list of really heavy hitter speakers, so and also topics. So I speak at other JUGs as well as around the country. Obviously, I live in Connecticut, so I speak in Connecticut quite often. The Connecticut Java Users Group in Boston is really close to me, so I love going up to the Java Users Group up in Boston. They call it the New England Java Users Group, or NEJUG. Just before all this virus stuff kicked in, I was in Milwaukee, and I went to the Milwaukee Greater Wisconsin Java Users Group. So it's nice to travel around the country and see different users groups. So looking at your list, you have a very good list compared to some of the others. So well done.
Well, thank you very much, because it turns out when I was at DevNexus, they had JUG leaders from all over the world there at a special presentation just for them. I met people from the Russia Java Users Group, the Guatemala Java, Paris, London, Chicago, New York, Seattle.
I agree.
Believe it or not, Seattle is going to get Gosling.
No way.
I kid you not.
That's awesome.
I don't know if they're going to do it online, but I sure hope they record it. So if you want heavy hitters,
that's good.
I don't think you get any more than Gosling.
Yeah, he's been going through some changes recently too. It's interesting. Yeah. Good. All right.
All right. Take it away.
I give this talk. I gave it New England Java Users Group, a Connecticut Java Users Group. I offered it to you. I was going to go to Dallas. That one got skipped. The Milwaukee one, I do a lot of speaking about Kubernetes. Most of the stuff I do on the No Fluff Just Tour and other venues and workshops, I talk a lot about cloud native. Now, one of the sub-talks of Kubernetes and cloud native is running is containers. It's getting our applications in containers. And this one resonates with me just because it's pretty exciting. And there's a lot of topics in here that are cutting edge. And it's an attraction to talk to Java users groups about this particular talk, because it's all about putting Java inside of a container. And I've noticed there's a couple of things that are going on in the industry right now. Java 8 has an unbelievable stickiness to it, in terms of a lot of people are still stuck on it. They can't move off of it because of the old style of, if you're in a Java shop, you tend to have one version throughout the whole shop. Everybody knows that version. And in order to go to that next version, traditionally in the past, it's been like moving an elephant to get into the next room. But now that we have on the 6-month cycle of Java releases, and there's all these new things coming out, we're more inclined to say, okay, what's coming on? Just recently in Java 14, this new idea of records, which is a very interesting concept, and I've already people are tweeting and talking about how much easier it is to write Java now that we have records. But that's not what this talk is about. This talk is about getting Java applications into containers, and I'm concerned about that just because I want to make sure that Java is continuing to move along in our world. So let me just bring you into my slides. Right here. Hopefully everybody can see my slides here. I talk about Java and containers because I was a little concerned about people getting distracted by other languages. Not that that's not appropriate, but there are also a little bit of bad press, especially with early versions of Java 8 and getting running in containers that I want to hopefully dispel. And maybe I can show you some new things that are going on with Java and how well they work with containers. So this is me, John Johnson. I live in Connecticut. And I do a lot of talking for No Fluff Just Stuff and a couple other things. I used to work for a company called Roche, and I wrote I was doing a lot of Java Swing on a DNA sequencing instrument. So one of the top 3 instruments in the country, in the world, was the 454 Roche DNA sequencing instrument, and did a lot of Java and Java Swing, user interfaces, and then got into laboratory information systems and interfaces with those. And moving a ton amount of data around, and I started getting in more enterprise applications. From there, I moved over to Thermo Fisher, got into like core informatics, Thermo Fisher, which is doing laboratory information systems. Then I started getting into the classic monolith to microservices, breaking up a very large application into smaller modular services, and then getting those microservices, services, and data stores into containers, and then running those containers onto Kubernetes. And that was around the same time frame where not only Docker was taking off, but also Kubernetes was also taking off. And since then, I've also worked for another startup company called Intelligent Artifacts Machine Learning Company. They're a startup company. I was there about a year. And since then, I've gone. Last summer, I went independent. I'm an independent software architect consultant, and do a lot of workshops and a lot of presentations like this, trying to evangelize and teach people exactly about some of the things you're going to be learning about today. So I usually have a live audience for this, and this software that I'm presenting on, I think it has a voting feature, but I haven't set that up yet. So it's very hard for me to vote and ask you questions. You could just type into the chat window, but it's more of a question of, have you packaged an application inside of a container, a Docker container, using Docker? And usually when I ask that question, and when I'm speaking to Java folks such as yourself, about 50% of the room, or maybe close to 75% of the room, their hands go up. Yes, I've put applications inside of containers. And the other question is, have you done more than just Java? Have you done other languages such as Node or Go, Bash shell script? Have you put that in a container yet? There's lots of things you can put in containers. And then the other question is, have you actually dealt with containers and put more than 2 together? Have you glued more than 2 containers together? And have you gotten to work in applications? And then another question I love to ask, and I'm sorry we can't get a survey here, but is how many of you have actually used a container? Hey, look at this. Okay. Thankfully, I have an elf in the background that has put together a few questions for us. So if you could try that, have you packaged an application in a container? Yes or no? You can answer that survey on the screen. I don't know if you can see the survey. Okay. Here is the survey. Let's try this out, folks. The new world of online presentations. Can everybody see the survey on the screen? I just need a yes. Okay, so thank you. You can see the survey on the screen. So if everybody can try answering these 3 questions. Have you packaged an application in a container? Yes or no? And what languages have you tried? And have you put more than 2 containers together? Now the question is, Thank you for participation in the survey. So I'm just taking a little time here. I'll see if I can see the survey in a moment. Survey results should be, sorry. Not finding the link for the survey. Well, if we can get, I don't want to take too much time for this and figuring out the software. So I don't know where that, there. Okay, I see. So all of the surveys have been done. I can now see them. I don't know if you, I assume you can see these on the screen. Have you packaged an application in a container? About half of you have. And for those who answered said no, 30 of you said no. What languages? Well, that's really hard to see as a bar graph, isn't it? So that's just telling me how many people actually answered the question. And I don't see any way to look at the list. Oh, I don't see any way to look at the text. So we'll skip that question. So the other question is, have you put more than two together? And a few have, yes. So I'm assuming that if you did put a few of them together, you've used something like Kubernetes. Maybe you've used something like Swarm. And there's a few other container managers that, or container orchestrators that are out there. So most of my talks are all about Kubernetes and container orchestrators and putting all this together. Thank you for putting that survey up. I'll go back to the presentation here. Oops. So that's the other question. Is like, not only if you could put something in a language in a container, would it be Java? And maybe you're in your organization, you only have the ability to put Java in a container, or only use container or only use Java in your shop. But the other idea is, if you could use other languages and they were allowed to be used, what would they be? In other words, if you're going to do an application by yourself, would you gravitate toward another type of language, such as Go or Rust or Kotlin? Or would you try variations of Java? Ken Cousin does a lot of talks on Kotlin. And there's lots of languages that are pulling us in different directions. The wonderful thing about containers is that we can put a lot of different languages into containers, because containers are not unlike the JRE. You can package once, run anywhere, and it's any type of language that you want to put in that container. Where traditionally it's been write once, run anywhere, so long as it was running on a JRE, a language that could run on a JRE. Now that world is opening up, therefore we're having more choices. But I'd also the point of this talk is to make sure that we don't go too far away from Java, and you understand that there's more that you could do. So in the chat window, just throw in maybe a language other than Java that you might be inclined to learn nowadays, knowing that you can put them in a container. Golang, there's one. Rust, Go, Groovy, yep, it goes in a container. Any Node.js folks? Yuck. That's awesome. I don't know that language. Anybody know the language, Yuck? The S language. .NET Core, yeah, that's another thing that you can put into containers as well and run them on Linux, which is interesting. .NET, as long as it's core. All right, thanks all. So there was an article that came out in 2017. In fact, it was co-written by one of my fellow speakers, Ken Sipe, who now works at the old company called Mesosphere, the new company called D2IQ, Day2IQ. They wrote this article, and basically the takeaway from it was, Java Virtual Machine doesn't work that well in a container. In fact, its isolation mechanism doesn't work that well. Yes, that's right. Thank you, Paul. I forgot. Ken Sipe is local to the St. Louis community, so hopefully he has been at a few of the Java users groups as well. Great guy, and I certainly don't mean to diss these fellows in any way. I just wanted to call out that one of these articles, and there's other articles that came out talking about if you're putting Java in a container, earlier versions of Java before they made some fixes to Java 8, some backports, there were some problems with it. Not only did it break out of memory, but also it wasn't behaving well and playing nicely within that container. Some would say that was a deficiency of containerization. And some would say, the JRE is actually being very aggressive in terms of doing things. For instance, what it would do would an early version of Java 8 would, the default version, the default setting for the heap size for Java when a Java application starts is to look at the available memory and take a quarter of it. The problem is that when you run in a container, what the JRE did is it looked at a quarter of all available memory, and it looked at the all available memory of the server, of the node that we call it, and instead of looking at the available memory of just the container. So what would happen is the Java application thought it had a quarter of memory, but it thought it had a quarter of a whole machine's memory, where in fact it only had a slice of the memory that was allocated for the container. And sure enough, you get an application that goes long enough and consumes enough memory. The application would actually hit the ceiling where the JRE thought everything was okay, but it would hit the ceiling of the container memory and the application would crash. So it wasn't behaving correctly. Now they fixed it, and they ported a back port for it. I'm going to go through the Java timeline in a second, but that was just an example of not playing nicely in containers, which my point is that has been addressed. Now, one of the things I'm going to talk about today is I'm going to go through a couple slides. I'm going to get through a couple points here, and then actually I'm going to show you a live demonstration. Hands-on demonstration of putting Java in a container, and we're going to go through a series of steps of distilling it down into as small as we can get. In other words, like squeezing the water out of the rock, so to say. But let me talk about what I mean about distillation. There's a pattern I'm trying to promote here is the idea of a distillation pattern. Fine whiskey. Here's a Lafroig whiskey that I love. That's an example of distilling a fine brew down into something that is very tasty and very consumable. You might want to call that peat ops. That's just a joke there. But the idea of distilling applications into smaller containers is something you really want to be doing, especially if you're running on Kubernetes, where your resources have been limited because you're on a distributed system. And every time you're on a distributed system, such as with the Kubernetes cluster, and you have lots of nodes, well, guess what? All of those nodes happen to be machines that are on that cloud system, and every one of those machines has a billable time on them. And the more machines you use, the more money you're consuming, not only resources, but the more money you're consuming. So it's important to make sure that all your containers are not very large elephants. They're very small little mice, so to speak, literally microservices. In other words, they're small in terms of their content. The smaller they are and the faster they are, the better your containers are going to behave on a distributed system such as Kubernetes. And that's what really, I see 8 factors related to the distillation pattern. A lot of people, a lot of engineers and you've all wrestled with these factors. So what I'm presenting to you, hopefully, is not going to be any surprise to you. What all I'm doing is I'm pulling them under one umbrella, saying that every time you work on one of these things, it's under the notion of the distillation pattern. And one of them, this is like computer science 101. I learned this from my professors in computer science school, and throughout my career, it's been true. And the reason I enjoy containers and microservices and architectures that are like this is because they enforce the idea of high cohesion and low coupling. High cohesion meaning everything that's in that package belongs there for a reason. And everything that's not related to that application or that package should be moved out. And we do that all the time in object-oriented programming when we're refactoring our classes. We're constantly looking at our classes going, are these member variables and are these members and these functions, these methods in here, are they all germane to the class that we're dealing with? And often you get drift with these classes and you look at these classes and you're like, you know what? I have a whole set of code here that I can actually be pulled out into another class. That's a refactoring opportunity we see all the time as architects and as software engineers, and object-oriented software engineers. And refactoring our code. So that's along the lines of high cohesion. In other words, take out the things that don't belong and then move them somewhere else or get rid of them if they're no longer pertinent or relevant. You open up in your IDE, IntelliJ, you open up a Java file, and at the top of the file, You have a whole bunch of imports, and voila, every once in a while, some of those imports are grayed out. Why are they grayed out? Because they're no longer being used. The IDE is determined, hey, you don't have anything, nothing's calling this import. Why do you have it here? And now you have an opportunity to remove it. That's, if you, as soon as you remove it, you're following this distillation pattern. So you understand the idea. And that could be applied, that idea of refactoring could be applied to classes, could be applied to all the classes that are inside your Java package, all of the jars that are inside of, or the classes that are inside your jar file, and all the jars that are inside your large, large jar file, such as a war file, and you can take that even farther into containers. Say, is everything in my container belong here or not belong here? So high cohesion propagates across all of our architectures, and if you're doing a good job at refactoring, that's following the distillation pattern. Low coupling is along the same lines, as well as making sure that, the other example for low coupling would be you've got a bunch of public methods in your class. And are all of those public methods, should they be public? You might get an IDE and some of those methods are grayed out, saying, hey, nobody's ever calling this method. Do you really need it here? And hopefully not through reflection, but hopefully you can determine that public method that's grayed out is no longer being called, and you can actually take it out. As soon as you take it out, you're reducing your API. You're reducing your exposure points. You're reducing basically your attack vector and coming into that class. And you're lowering the coupling. But you can lower coupling with your REST APIs as well. There's a lot of different ways of lowering your contact points where other things need to access your calls, and that plays true obviously in microservices. If you expose something on a REST call, you want to really intentionally understand what your API is exposing and not exposing. So reducing those two things is part of the distillation pattern. Another part of it is immutability, making sure your containers are immutable. We talk about immutable classes in Java. You can have immutable containers as well. In other words, striving for the fact that once you build that container, nothing's going to change in that container at runtime. In other words, inside your container, you can run an application and you can have a package manager inside of that container. I would question, why do you have a package manager inside your application? If you bundled your application inside of a container, what needs to change inside of the container? If it does change and something goes wrong with it, how are you going to debug that? The more immutable it is, the better it's going to be for you to be able to, the more it's immutable, the more it's distilled. The more it's distilled, the easier it is to test and understand exactly what's going on inside of that container. Idempotent. Usually I ask everybody in the room, and maybe I can survey on the chat window. Does anybody know how to break idempotency? So there's an anti-pattern that's going on in the industry. Does anybody know how to break idempotency? Idempotency basically means every time you run something, it runs the same every time. People running like Node.js with NPM and everything, they run a Node.js application, and imagine writing a Node.js application and then rerunning that application in 6 months. Do you think it's going to run the same way? And if it doesn't run, what is causing you to feel like, oh no, something's going to break here? What's usually the fact? What causes something to break over time? Causes something to break the longer time goes on. Can we take a guess at it? Side effects, yeah, definitely side effects. And let's get a little more specific. What's the side effect that's causing the container to break based upon time? State, that's an interesting one. Hopefully you've made it immutable, so therefore the state doesn't change. So let's assume that you have this immutable container and state doesn't change. Yes, Paul, external dependencies. That's what I'm trying to get at here. How do you cause dependencies to break? Old packages, yes. There's something that we do in our industry related to breaking dependencies. That's an anti-pattern. See if guys can come up with it. Give it another couple seconds. Old packages. Yes, that's related to version dependencies. Updating Java. Dependency hell. You're all on it. You're coming into the focus of exactly what I'm talking about. these dependencies, updates, you got old stuff in there. How do you, let's see if someone can come up with it. I don't want to go too long. All right. Anybody? Okay. Transitive dependencies, and this is also related to it when I'm trying to get at. Yes, transitive dependencies. When you have a third-party application and that third party relies on another third party, and then sometimes you have a tree where you have two versions that of the same package and they're of different versions. And I would say transitive dependencies is one of the biggest ones about item potency as well. That makes it difficult. But there's another one I want to get at. Anybody know about Semver? Semver.org? This is a good thing to know. Let's sure I can. Semver.org. Good thing to know is this. This is a website describing, postulates to say have a major, minor, and patch for your version. And the anti-pattern of semantic versioning is using a version, and we've done this all before, of latest. That's what I was trying to get at. If you use latest in your dependencies, that is a great way to break item potency, because the next time you run that Node.js application and it does a yum update or an npm update, and it gets the latest, well, that latest package may have deprecated features that have been removed, and therefore your application no longer runs. So if you can define things up front statically as much as possible, that's what item potency is about. Two other things related to the distillation pattern are making sure you're attack phobic and small images. Attack phobic meaning don't allow nefarious or even just expose yourself in a bad way so that somebody can do something either nefariously or just accidentally. Sometimes that happens with security as well. Some people just accidentally stumble across a security problem. Also, making your images very small is part of the distillation pattern, and that's very important. It's related to containers. We're going to go through a hands-on exercise where we're going to reduce our container down to smaller and smaller sizes as part of the distillation pattern exercise. The smaller you make your images, the faster they can be moved around. We talk about massive scaling in Kubernetes. Say you have 1,000 microservices that need to spin up to purchase concert tickets. All of those microservices that purchase tickets need to spin up across multiple nodes across your network. Therefore, all of those images need to come down from a repository. The smaller your containers are, the faster all those microservices can spin up because they're smaller in terms of download time. The latency, mostly when it comes to cold deployment of things, it happens when the containers are very large and they take a long time. The startup time is what is the slowest when it's cold because of the size of the image. Two last ones are rapid startup. So that's kind of related to small images. Not only do you want a small image, but you want the application to start up very rapidly. Java itself has suffered tremendously from slow startup times. Now, in the past, it really hasn't been a problem because we were used to dealing with servers that are more like pets. In other words, you stand them up and you keep them running, and you never really want to shut them down unless you really, really have to. And that's the pet mentality of running servers. Kubernetes embraces the idea of cattle. A better way to say it is I don't know. It's not a good way to talk about animals this way, but you get the idea. Is if you treat these containers as more disposable, you're in a better situation. You're in a better situation to be running on a distributed system like Kubernetes. And if you have all of these cattle that are being restarted and scaled up and scaled down, that rapid startup comes into play. So you definitely want to have rapid startup, but if you're running Java in a container, there's a concern about rapid startup. So there is a switch inside the JRE that'll say, yes, I'm a desktop application, start me up as fast as possible. So it starts the application as fast as possible. The other way to do it is slow startup and load all the classes up front. Because you don't really care about startup time. And that's typically for older types of servers. But in this new world of containers, not only it's a server, but it also needs to start up very rapidly because it's more of a microservice. And then you get into resource frugality, meaning if once you are a container and you're running, don't consume a lot of memory and CPU. That's what Kubernetes does as an operating system. It takes care of managing memory, CPU, and I/O. And if you are consuming a lot of CPU, memory, and I/O, you're not playing as a first-class citizen of the Kubernetes cluster. So it's one thing to put Java inside of a container, but if you're not addressing these 8 distillation patterns, you're not playing well as a container running in Kubernetes. So it's one thing to know that there's 17 commands in creating a Dockerfile. But if you don't do the best practices, reducing and keeping things highly distilled, then you could have problems down the line in terms of incurring more costs, having insecure containers, being slow to start up. And this is where I think a lot of people might be thinking, oh, well, maybe I should write it in Go, or maybe I should write it in Rust. That's a very fast language to write containers in. And I want to say, don't go too fast. All right. So in Java to containers, I just want to talk about a couple things. I want to talk about the timeline for Java 8. I want to move a little bit faster here because I'm sensitive to time and I don't want to run over time here. But Java 8 was released in January, March of 2014. And there was a lot of issues with it, especially related to containers, and that have been patched over time. And now we're on the 6 months release cycle. Every September, every March, we come up with a Java release. And now what just got released is Java 14, which has some great features inside of it. And people are getting pretty excited about it. Java 14 is a major release. So over time, what happened, and then the 15 is coming out next September as well. So what happened is in Java, remember I talked about that memory issue of running Java in a container. Ken Sipe and the other fellow wrote the article about that. Was before Java update 131 and 191. And some folks in the industry as well, like Fabric 8, did some things to make a workaround for it to make sure that Java 8 behaved nicely in the container. But while engineers were working on Java 10, they were looking at some of these JDKs and JEPs, and they were looking at specifically JDK 8186248, and they were looking at the heap size allocation with containers and the improved Docker container detection and resource configuration. So they added all those fixes to Java 10 and realized it was so important. They actually did a backport, and that was the reason for update 191. So if you are using Java 8 in a container, make sure it's a version that's above or 191 or above. And there's a lot of things that have been added to Java that is following the distillation pattern. In Java 9, with the advent of modular system, the whole project jigsaw, now we have a new utility in there called JLink. What JLink does is it looks at your jar file, or it looks at your class file, it looks at your war file, and it looks at all the things that you're using in Java. Basically, it looks at all your import statements and sees your code, and it says, okay, this is Java 9 with all its modules. If you're not using JDBC or SQL, there's no reason to have that module inside there. So what JLink does is it will create a new JRE for you without the Java SQL inside there if you're not using Java SQL. There's a whole bunch of modules that can be stripped out of the JRE that you don't need, which is what you want, because when you load that JRE into a container, you want a small distilled JRE that can still run your application, but doesn't have all the other fluff in there that you're not using as part of your dependencies. So that's what JLink does. When I first saw JLink, I was like, oh, cool. Now they have a compiler for your Java application. No, it's not a native compiler for your code. It's a recompiler of the JRE to be strip it down. And it also uses a dependency application called JDeps, which is a dependency mechanism. If you run JDeps in your binary in the bin directory, it will create a dependency of it will create a report of all the dependencies it finds, or the Java dependencies it finds within the application. And JLink uses that to create a new JRE for you. There's other things like ahead of time compilation, which is kind of comparable to just-in-time compilation. The idea of like as the application runs, it can self-compile and make essentially binary bytecode that is native to the operating system and to the machine that it runs more efficiently, caching that. That's a high level way to describe it. Ahead of time compilation looks at your code statically at build time and does the same things that JIT does, but it does it more ahead of time. Java Hotspot doesn't do that, but there's a new replacement for Java Hotspot called GraalVM, and that implements ahead of time compilation ideas. So those things are being added to Java. New things are being added to Java 11. They finally said, yeah, let's take the Corba modules out. Great. They're following the distillation pattern. Take out all those old deprecated things, take them out. There was a rewrite of the transportation layer related to security and TLS. Good thing. They're upping the security. That's the distillation pattern, making sure you have a low attack vector. That's a good thing, too, because all our applications are going in containers, and we're all connecting these containers using basically socket connections, and a lot of those connections need to be TLS. Many other things that are being added. Another one I'm going to be talking about is the default class data sharing CDS archives. That's the idea of, I'm going to get into a slide about that in a few seconds, but that's what was added to Java 12. And of course, GraalVM is taking advantage of CDS as well. Uncommitted, unused memory, the reimplementation of the socket API, new types of garbage collections and refinements to the garbage collection, ideas about non-volatile memory, where you can have memory that's actually backed up with actual file storage, so you don't lose memory when something crashes. These are all things related to resilience and the distillation pattern. So I find that very interesting. So JLink, like I said, is a nice utility that will remake a JRE for you. And that's a really nice thing to do, especially if you take your JRE and you put it inside of a container along with your jar file, you now have an application that's containerized. But in order to containerize your jar file, you need to have inside your container, not only an operating system such as Linux, like Alpine, but you also need a JRE inside of there as well. That's so we can maintain that write once, run anywhere. So we put a JRE inside of that container that runs with Alpine or Ubuntu or whatever base operating system you have inside your container. So, so let me just point out, I mentioned the fact that you do write once, run. For many years, we've been doing write once, run anywhere, right? And we also do package once, run anywhere with containers. The idea, and these are very similar ideas. As a developer working with containers, I feel like when I put an application inside of a container, I feel like I'm writing a Java application and I'm running it on a JRE, because it's the same idea. A container runtime engine will run a container for you. A Java runtime engine runs a Java application for you, or anything that's written that will run the JRE. So if you think about it, now we're dealing with two technologies that are actually doing the exact same thing. I want to be abstracted away from the layers below me. So why is it that we have a runtime engine for containers, and inside that runtime engine, we have a JRE that will run anywhere? That's kind of silly, right? If you think about it, inside the container, we know exactly what the operating system is. It's some version of Linux. So why do we have a JRE that can run anywhere when we know exactly what's inside that container? It's Alpine, it's Ubuntu, it's Debian, whatever it is. So I have what you really want to do is have a JRE that's defined for that Linux environment, because the run anywhere is taken care of by the Docker containers now, and it's fully polyglot. So you can run anything in a container now, and you're not limited to just the languages that run with the JRE. So if you think about that, this is a violation of the distillation pattern. You've got two things in this technology stack that are running anywhere. So wouldn't it be nice just to say, oh, well, I know what the operating system is. Here's my Java code, compile it. It's exactly what I'm going to get into with what GraalVM does. GraalVM has a compiler. It allows you to compile your code, so you don't have to put a JRE inside your container. We're going to do that with a hands-on exercise. I'm going to show you how much smaller it makes your container. So there's lots of Java frameworks out there. Obviously, probably if I ask the room right now, how many of you are using Spring Boot? About all but one of your hands will probably go up. That is the elephant in the room. A lot of people tend to use Spring Boot when they're writing Java and they're putting them inside of, and they're writing microservices. And again, you don't have to, if you're writing microservices, you don't have to put them in a container. And if you're writing containers, they don't all have to be microservices. So there's just two technologies that work well together. I call it peanut butter and chocolate. I wouldn't, as an architect, I wouldn't do microservices without containers, and I wouldn't do containers without thinking about microservices. Two independent architectures that work well together. And when you're in the Java world, most people tend to go down the Spring Boot route and putting those in containers. Vertex is another one, Dropwizard, Javelin. There's a few others out there, but dominating the industry right now is Spring Boot. But what's emerging is three that are inside that gray box: Micronaut, Quarkus, and Helidon. In fact, Michael that was just on, for No Fluff Just Stuff, does actually a lot of talks about Micronaut. And their Quarkus is being promoted a lot by Red Hat. So these are micro frameworks to help you write microservices or REST-based applications, or gRPC if you're using those, that are running inside of a container, that don't use, that are, they feel a lot like running Spring Boot. In other words, you're still annotating your applications with annotations, and things are set up for you nicely. But the key thing is that Spring Boot, when it, at runtime, figures out what it needs to do by using a lot of reflection. What Micronaut, Quarkus, and Helidon do, they're all based upon GraalVM, and they rely on static code analysis and looking at the code at build time and figuring out all the things that need to happen. And they don't figure it out at runtime. They figure it out up front at build time. Why? One of the reasons is for the distillation pattern, to make sure that you can compile your code up front at build time rather than doing things dynamically at runtime. So I believe that there will be a shift in our industry toward more having things be defined up front at build time. The rub there is, if anything, if your application is using Java reflection and doing any kind of dynamic loading of classes, then what Spring Boot is all based on, GraalVM has a hard time dealing with that. There are ways around it, and they're working frantically in terms of getting Spring Boot to work with GraalVM. But frameworks like Micronaut, Quarkus, and Helidon play nicely with that upfront static code analysis. Micronaut is sponsored and developed by Gateway sponsors. Yes, that's right. OCI. Thank you. Thank you for that. Excellent. So you guys, maybe you've already had talks on Quarkus and this talk. I'm not sure. If you haven't, get somebody in there to talk about GraalVM. And if you don't know anybody, there's a couple No Fluff Just Stuff folks that can also talk about GraalVM more than I can. But what I'm going to show you is just showing running GraalVM inside of a container at the end of this. So one of the things that GraalVM does is it does this app class data sharing. And think about runners when they're doing a race. When you're starting, this is your application that's starting. What Java has to do traditionally, it has to do these things. It has to look up the class on the disk. It has to load the class, has to verify all the bytecode, and then has to put this into a table, into an internal data structure. But if you knew, right, when I was talking about at build time, if you knew exactly what all the classes are your application is going to use, then the compiler can actually look at everything it's going to need to load, and it can create that data structure at build time rather than incurring that cost at runtime, especially incurring that cost not only at runtime, but at startup time. So if you can create that data structure and pass it along with your binary so that when you run your application, that data structure is repopulated, you have a much faster startup time. I'm going to show you a graph of how much faster that startup time is. Warning, they're not just Java compliant. Yes, I also want to say, like Micronaut and these other frameworks, Quarkus, Micronaut, GraalVM, it's emerging tools. These are kind of cutting edge. Not a lot of people are using them. There's still some bugs and things that are being worked out with it, but it is moving along fairly quickly. It's fairly nice. So here's an example of startup time, just a small example of it. Above, You can actually turn on the GraalVM hotspot. It's a replacement for the hotspot compiler. You can put a switch in there, and you'll get right out of the box faster startup times just by switching it. So you just add that switch, share off, that will enable GraalVM in, I think, Java 10 or later. Okay. Move on to the next one. Ahead of time compilation is related to also looking at the startup time of, especially that plays nicely with containers. You want fast startup times. So just like just-in-time compilation, the idea of ahead of time compilation is looking at all the startup time of your loading your classes and making sure that they load faster. I'm not going to go into the details of actually how it works. The idea is that there's optimization that's going on at compile time to make sure that the startup time is as fast as possible. And that's done with the ahead of time compilation. That was experimental in Java 9, and now it's the feature that's inside of 14 as well. So GraalVM, developed by Oracle, replacement for Hotspot. It also is supporting non-GAVM languages, kind of interesting. You can take Node.js, Ruby, and Python and R and run those in Graal as well as a VM. And GraalVM is an implementer of both CDS as well as ahead-of-time compilation. But what I love about it, because it plays nicely with containers, is the fact that there's a linker. There's now a linker called native image, where you can give it a jar file, and it will not only run JLink and do modular Java, but it will actually create a binary for the operating system that you target. So now you can link Java and make a binary, a native binary out of it, which is exactly what you want inside of a container. Because if you think about it, now all you have to load, the only thing you need to load in your container is your compiled binary. You don't have to load a JRE in there anymore. Okay, well, what about garbage collection and all those things? Okay, yes, the GraalVM is writing all of those things in terms of garbage collection, and all the other niceties that you have within the Java ecosystem are also inside of the GraalVM as well. But it's baked into that binary that you get. And that binary is very small, and it loads very fast. Daniel Hossa, another one of our No Fluff Just speakers, does a talk on, he has it called Graal the Magnificent. And he might actually be doing a workshop on it in the next couple of weeks. I'm not quite sure. But he's another person you can ping about, hey, how does Graal work? I'd be happy to answer your questions. So like I said, there's 3 projects that are going on, Helidon, Micronaut, and Quarkus, that are all embracing GraalVM and thinking about how to run Java applications with Graal. Helidon is promoted by Oracle. And Micronaut is its own independent project, as well as Quarkus, which is being promoted by Red Hat, now IBM. Now, I said there's 3. Yes, okay, actually there's a 4th one, unrelated to, well, it's kind of related to containers. What Piccolo did is an open source project that said, Java, slow startup time. Nobody's using Java for writing command line tools because it's too slow to start. And but there's actually a command line third-party jar, I forget the name of it, that runs, it's a third-party jar that you can add to your Java application, and it allows you to do command line parsing of arguments. If you've ever done that yourself, some of you probably have. You get into it and you're like, oh, this is easy. How hard is it to write a command line tool to parse the command line parameters? Well, it turns out that it actually is complex once those parameters start growing. So there is a nice third-party. There's a couple of third-party utilities out there that help you parse the command line tools. But what the Piccolo project did says, okay, I'm going to take a command line tool, open source project, and we're going to combine it with with GraalVM. And now we have a compiled application that's native binary that starts up very quickly, that does command line processing and allows you to write it all in Java. So that's kind of a nice thing to say. I'm just looking at some of the chat stuff that's going on here. Oh my God! Warning, they're not JES compliant. Okay, that was from before. Thank you, Paul. Here's the slide I wanted to show you. This is if you go to the GraalVM site, this is right on the main site, on the main page there. That's where these 2 charts are from. But I just wanted to call out the fact that once you have an application, the gray bars on the left-hand side are the traditional startup with just the hotspot compiler or the hotspot runtime engine. And the orange bars are the startup time related once it's compiled using either one of those frameworks. Now, the difference between the frameworks is not much. The key thing is that it's not 50% faster, it's 50 times faster. That's significantly huge in terms of startup time. So great, that's now satisfying the distillation pattern. And on the right-hand side, part of the distillation pattern is also making sure you're not consuming a lot of resources. And it turns out that when you run it with a GraalVM, it consumes a lot less memory. So not just 50%, 5% lower, it's 5 times lower, which is significant too, which means that you're going to be using, that your Java applications are costing less for you to run them on your distributed cluster. See? Okay. Quarkus, Red Hat, they have graphs as well, how well things and how performant they are. If you want to learn how to do Quarkus, they have some very nice online tutorials called Developing Quarkus. And if you go to learn.openshift.com, you'll get a website like this. And each one of these tiles is a different course. One of them is Quarkus. It's probably, yeah, Develop with Quarkus is the first tile. And if you go into that course, it'll show you, different ways to get. So getting started would be a hello world for Quarkus. So highly recommend you to jump into that. And again, Quarkus is it's a framework like Spring Boot that's using GraalVM underneath the covers to run everything. Okay. So another one to look at, of course, there's decision paradox. Here's Piccolo. That's the command line tool to allow you to run command line utilities with Java that gets compiled native. And I didn't show the other two, but Micronaut and Quarkus are the other. Quarkus, Micronaut, and Helidon are the three. I think the No Fluff Just Stuff speakers like to talk about Micronaut in terms of buzz, but the other one that's being heavily promoted is Micronaut, and I think the one that's being less talked about is Helidon. I don't know why. I'm not sure what the reason for it is in terms of the industry, but those are your three choices. I don't know which one is more popular to go with nowadays, but I'll leave that up for you to make that decision. So Java in a container, like I said, how hard could it be, right? I got my application hello world class file. And if I take a jar, if I take my JRE and I just put it inside a container, that's all I need inside my Dockerfile to create it, right? Just drop the mic. What I have to do is declare that stack, add it as add my payload to it, build it, tag it, push it, and run it. So that's the brute force way of getting Java in a container. And when we do that with our hands-on exercise, they're going to show you how fat that container is. Not how fat the jar is, but how fat the container is. I want to move on to this Java JVM ergonomics is another feature within Kubernetes, within Java that's been there for a long time. Base containers. This gets a little complicated. I just want to navigate you through this a little bit. I'm just reading this. Micronaut has a similar set of introductory guides and tutorials. Yes, it does. Micronaut is very well documented. Thank you very much, Zachary, for pointing that out. I should pull those out on the slides as well. And by the fact that I went to the Red Hat site, I'm not trying to promote them in any way. I'm just saying, hey, there's stuff out there for you. And thank you, Zachary, for calling that documentation out as well. There are different base containers out there. Alpine, you've probably heard about, is being a very small container. It's about, Alpine is really nice because it's about like 4.5 megabytes in total size in terms of base image. And if you look at things like minimal Ubuntu, which is Ubuntu was just stripped down minimal to run inside a container, no GUI inside of it, it tends to be about 29 megabytes. So that's a 5-fold difference between Alpine and Ubuntu. Red Hat OpenShift has a minimal base image. There's minimal base images out there that are based on Debian, that are based on different operating systems. And there's also distroless ones that are even more minimal. Linux, they just have very rudimentary base systems inside of them. These are all base containers that people are saying, I want to derive from these and add my Java application to. And when you do that, there's a problem with libc. So if you think about it, let's see if I have a slide for it. Yeah. So So here's your application, right? So you have an operating system you're running on, and on top of that operating system, it needs, in order to communicate with the kernel of that operating system, for Linux, you need a library called libc, which is the library that allows your application to communicate with Linux. And typically you would have like a C++ application that links to libc. So it turns out all the JREs are written in C++, and they all have links to libc. So this is why you're going to see, like, yes, this is the JRE for Alpine, and this is the JRE for Debian, because they have very different libc packages inside them. So Alpine uses one called MuselC, and one of the reasons why Alpine is so small is because MuselC is very lightweight and efficient. And there's the Debian ones have a more traditional one. It's called GNU-C, which tends to be a little bit heavier weight, but is very dominant in the industry for Linux and compiling with your applications, binary applications with Linux. So there's a dilemma right there. Every time I make a JRE, I have to compile different versions for these different libcs. There's also security C, sec-C. There's a couple other libraries in Linux you have to compile to, but the major one is the libc. So that's the dilemma. And what happened was when all these Java versions were coming out with OpenJDK, they kept kicking the can down. They kept kicking the can down the road, because when they started coming out with Java 10, if you went to the release notes, it said, yeah, we're not doing anything with MuselC right now. So therefore, you didn't have a JRE that ran nicely with, from the OpenJDK community, you didn't have a JRE that ran nicely with MuselC and Alpine. So other folks came into the light, and they were like, again, so OpenJDK did not support Alpine version 8 to update 2.12, and then all the way up to Java version 13, there was this void in here where they weren't supporting Alpine. So anytime you wanted to have Java in an Alpine container, you had to figure out a different compilation of the JDK in order to run an Alpine that would be linked with MuselC. Okay, we're kind of into the weeds here. But so some open source projects came out, adopt OpenJDK. They fully embraced, hey, we'll make sure that it works with Alpine. Small group. It wasn't being supported that well. It's a big undertaking to write a binary for JDK. Who are they? Are you going to be willing to trust these applications, these JREs, to be running inside a container? It's difficult to do. Portola was another one saying, yes, well, we're going to take it's a subproject of OpenJDK that does a port to Alpine to support the MuselC library that makes it very small to run your containers. Again, all addressing the distillation pattern, that what this talk is all about. Azul Systems, they do a really nice job at creating a commercial version, paid version called Zing of the JRE, mostly coming out of the financial sector and fast financial transactions. But they also have a community edition called Zulu, and they fully embraced taking care of MuselC. But again, it's not OpenJDK, that whole route. It's not. It's their own compiled version of OpenJDK called Zulu. So they were coming out with versions of Azul that runs in Alpine, as well as CentOS and Debian and a bunch of other base containers. So I just want to let you know there's a bunch of them out there, but it's been fixed in 13 and 14. And OpenJDK works with Alpine again. Dockerfile. If you haven't looked at a Dockerfile yet, most of you have, I assume, but if you haven't, I just want to point out the fact that here's that from command, and the idea of a from command is you're standing on the shoulders of giants. So somebody has already written a container called Nginx, and inside of that Nginx container, there's a base Linux version as well as Nginx that's been put inside there. So you're standing on the shoulders of giants, and what you do is you just do a copy command saying, I want to copy my static content into the opinionated directory where Nginx expects it. And with 2 lines of code, you have the definition infrastructure as code of your container. And this defines a static container. And there's about 17 commands you can allow to do it. And, that's 2 lines of code, 4 lines of code in a Docker file. You can put a Postgres database, populate it, and seed it with data inside of it. 4 lines of code. You can take a Spring Boot application, and take a container that's based on JRE Alpine. I would do it with 14 now that it has 14 with Alpine. And I would run, you could take a Spring Boot application, add it to your container, and then give the Docker command, the Java executable jar command, which is java-jar, my jar executable jar file, expose some port, and voila, you have a Spring Boot application running in a container. In this case, it happens to be a microservice. Voila. 4 lines of code, you have a microservice written to infrastructure as code as your Docker file. That's the beauty of Docker files. But like I said, it's 17 commands in a Docker file, and there actually can be some mistakes that you do in it. Like I said, that drop the mic slide, how hard could it be? And this is this drop the mic slide. Take the JRE, put my jar file in it, stand it up. What do I have to do anything more? I would say yes. This is actually pretty fat, pretty big in terms of its running size inside of the JRE. And who knows? Look, I'm using latest. Remember I talked about that anti-pattern of using latest? This is essentially saying latest. I'm not actually defining any version of the container out there. And I'm not sure if this is using, after update 191. I'm sure it is, but, buyer beware. All right. So the other thing I want to introduce, and we're going to do this in the hands-on tutorial, we're going to do a multi-stage Dockerfile. What multi-stage Dockerfile is this, you haven't looked at it before, is it has the ability that within the same Dockerfile, you can have multiple stages that are going on. The last stage is the only layers that are actually in the container that are running in production, right? So the first stage right here, if you look at this, what this is doing is it's taking Golang and it's taking the compiler for Golang, and inside of this container, it's actually taking the source code called app.go and compiling a binary and generating it. And once that Go binary has been created, once that Go language has been compiled to a native binary, you don't need all this compiler stuff anymore. So what you do is you just take the application and load it into. Yes, that's a very old version of Go. Thank you. I do need to update the slides. You're right. But this is the classic one where you see multi-stage containers and they show Go and building it this way. Now, in Java, if you just need to build a jar file, you don't need a special version of some Linux version. You just need to run the compiler, create the jar file, and because it's the jar file is run through it anywhere, it's different. But remember I said about GraalVM. With GraalVM, you can compile it to a binary. So now you're starting to get in the idea of like, well, if I'm compiling a binary, I'm probably going to need multi-stage containers. In the hands-on tutorial, I'm going to show you running GraalVM with this multi-stage Docker file. I just want to introduce you to you in the slide right here so you can understand. I hope you understand that. It's the idea is, you wouldn't do these steps inside of your Maven or Gradle build. You would do these steps inside the container because you actually want this container version, this version of Linux, to be the same as this version of Linux. So because you want binary compatibility between where this is compiled to where it actually runs, and this allows you to do it. It's not really well illustrated that these are binary compatible, but Golang, this from container is compatible with Alpine in this sense. So if we load this compiled binary into this operating system, it's all going to run. And again, this all gets thrown away. So it's not part of your, it's part of the distillation pattern of throwing all these layers out. You can actually have multiple stages that are leading up to it. Another stage might be do a git clone and pull the source code. Another stage would be building it. And then maybe the last stage is actually running it in production. Okay. So lots to lead up here. I'm going to skip this slide. This is just saying, hey, there's lots of containers out there that run, and lots of people are pulling down these base containers to run your applications. Java is at the top of those top 12 containers that people are pulling down. So still, Java is very relevant. Everybody remember Shrinky Dinks? You little plastic things you decorate and then put them in the oven. As a kid, kind of dating myself a little bit. Well, here's a little tool that's related to Shrinky Dinks, related to the distillation pattern. It's called the dive tool. And it allows you, after your container is built, it allows you to explore all of the layers inside your container. And you can actually look at all the artifacts inside your container. And as part of an engineer, you can look at all these artifacts and going, wait, why is that? We do that. Remember, I said we do the same thing with our classes. We go to our classes, we look at imports or member variables or methods, and we're like, hey, this is not being used. Why is this in this class? So this is a tool that allows you to statically go into the container, look at it, and go, why are these artifacts in here and being built in here? I don't want those in here. You can actually just strip them out here, and there's also a command line interface for it as well, so you can do stripping of artifacts out of containers after they're built. There's another tool called Minify, Docker Slim, that will minify, not called Minify, it's called Docker Slim, and it will look at your container and also do the distillation pattern and strip things out of that container that it sees that it's not needed at runtime. It has a pretty intelligent way of doing it. And it does it for lots of different languages, not for Java. I highlighted the Java one here, and it is a case where they did an analysis of one particular Java application. I don't know what the source of it was, but they looked at all the things they could strip out, and they stripped it down to about 100 megabytes. We're going to do better than that in our online tutorial. So those are some of the tools you can use. CI/CD is really important. I wanted to pull out one of the things about containers themselves, and I kind of want to demystify what containers are all about. If you haven't looked at them, try this exercise at some point at your leisure. Do a Docker pull. Just pull Redis. Docker pull Redis. Pull it down, and then run the command called docker save output. And you can output that image to an actual tar file in your local system. Because guess what? Containers are just tars. In fact, it's a hierarchical. It's a tar of tars. So every layer inside your container is a tar file with artifacts inside of it. And then the container image itself is just a tar file. And of course, Docker does all these great things with caching of all the layers using checksums to make sure it's not unnecessarily pulling down layers that it already has locally cached. But I want to get into all that now. I don't want to get into the aspects of caching and Docker, but I just want to let you know that it's pretty easy to look at these tar files and then see what's inside of your inside your containers. That's exactly what that other tool is doing. It's just opening up the tar file and looking at all the artifacts for you in a visual way to see what's being loaded in there. Okay. So that's just demystifying. So there's actually, because it's just a tar of tar files, there's lots of tools out there that will help you build containers. And by the way, it's not just Docker. You don't have to use Docker to build containers. To build containers or to run containers, there are a lot of competing tools out there that will do it for you. Traditionally on the left-hand side, if you're using Gradle or Maven, there were these plugins that allow you to build containers using your Docker tools. But there's now new tools out there called that will also build these tar of tar files. They're called OCI images, Open Container Initiative Standard Format. So Kaneko, or Kineko, I don't know how to say it, and Builda and Podman and Image and Orca Build will also build these containers for you, and you can put them inside of pipelines like the Tecton pipeline tools that will build these images for you on the fly inside your pipelines, all running on Kubernetes, running in containers. It's pretty complex world to do CI/CD related to containers on Kubernetes. That's another talk I talk about. I don't want to get too far down in those weeds, but I just want to let you know these are just tars of tars that were being built up. And the key thing is you really want to make sure that they're efficient. And there's best practices, not only with the Docker command line tools, with the Docker commands, such as the 17 commands, but there's also distillation patterns you can use to apply with these different ways to build containers. So, and by the way, if you build a container with these different tools, they will all run on a compliant container runtime engine. So just like how you can use different tools to build Java code and run them on any JRE, you can use different build tools to build containers and run them on a container runtime engine because of compatibility between them. So, yeah, and I would look at things like Cloud Native Computing Foundation and Continuous Delivery Foundation to get more into pipelines and builds and these types of tools. don't want to get too far into it. There's also places where you can install registries. You can run registries right on Kubernetes. Last year, I used one called Harbor to store registries. There's a bunch of others out there. Highly recommend understanding what registries are all about and how to run them. Then you also get into container security scanning related to containers. So once you've built up your application, Java application inside of a container, it's also really good to run your static code analysis or static security analysis against your containers. One of them that's open source that's very popular is Claire. I highlighted in here yellow. That looks at the CVE database, the NIST National Vulnerability Database, and it looks at all the security aspects, and it will run scans against your container as well as all your base containers and look for any violations, security violations, and it'll generate a report for you. So you can run Claire on your registry as well. And you can also run Claire live on your production server. But really the best thing to run on your production server is something that's a new one called Falco, which is from Sysdig. It is an auditing tool that doesn't look at your security from a static code analysis or static container build time. It looks at your container as it's running in production and does security audits as it's running. It's actually considered a better way to look at security of your containers. I talk about that just because it's part of the distillation pattern, reducing your attack vectors. Okay, but I didn't mention it. Remember I talked about Docker Slim open source project? That also looks at security issues within your containers and will generate reports for you and also remove security vulnerabilities. If it finds them, it can remove them. So I don't want to run out of time here. Bruce, I don't know how much time we have for this, but I don't know where we are with time. It's probably a good hour and 20 minutes into this already. This next part will take us, about probably another 20 or 30 minutes, and then we can open it up for questions. That's about where we are right now, okay? I'm going to dive right into it. And what I've done is I've written a katacoda that will take us through this adventure of distilling a Java application, Spring Boot application, into something that's pretty fat, and we're going to get it down to something pretty small. So I'm just looking at your chat window to see if you have any comments so far, questions. But what I've done, while I load this up, I'll look at the chat window. I write a lot of katacodas. These are little scenarios that give you examples about how to do things with your paws right on the keyboard. You can actually play around with a lot of technologies. There's katacoda scenarios for Docker to learn how to do Docker, how to learn Git, how to learn Linux, how to learn Java or Kotlin. There's all these scenarios that are being created by different authors that are being published. These are all free, by the way. O'Reilly has one. I'm doing a lot of writing for O'Reilly and putting O'Reilly scenarios up on their Safari site and their subscription site as well. So yeah, you got to love katacoda. If some people, it looks like you already had some experience with it. It is a great way for you to really work on your fingers and memory muscle and experience with different platforms. But let me, without further ado, let me drive right into it. So one of the patterns I have, so if you go to javajohn.com, it's all free, by the way, no credit card, doesn't ask you for an email or anything like that. If you go to katacon.com/javajohn, you'll get to all of my courses. And one of the courses I have is called Kubernetes Fundamentals. And layered deep down under fundamentals is I have this tile or scenario called Distilling Java Containers. So what we're going to do is we're going to spin up. We're going to click on, I just clicked on that. And we get a nice welcome screen. Good thing since I'm drinking. Awesome. I wish I was. All right. So we're in the scenario right now. On the left-hand side, we have Markdown. That's going to take us through 10 steps. And we're on step 1 right now. On the right-hand side is a cool thing. So it's all cool right here. So we have on the right-hand side a bash shell script, a bash terminal. In fact, let me open. I'm going to go to presentation, but I don't think we need it because we're all online and we all can see our screens. Hopefully everybody can see this nicely. So right here, I actually have a Kubernetes cluster. So if I say kubectl get nodes, I have a 2-node cluster. It's called master and with a master node and a worker node. In fact, if I say get namespaces, I have a cluster that has some namespaces in it. And if I say, hey, get me the nodes, get me the pods. I don't have any pods in the default namespace, but if I look at the pods in the kube system namespace, lo and behold, I have all the basic components of what makes a Kubernetes cluster alive and ready for me. In fact, I can just click on these commands over on the left-hand side, and it will fat finger those commands in the bash shell terminal here, and it shows me that I have a Kubernetes cluster 1.14. It's a little dated, but we're up to 1.18 right now. And we have a healthy cluster. In fact, we have a Kubernetes dashboard behind it too, and I'll show that to you right here. If you click on the token, I have this. Oh, interesting. For some reasons, every once in a while, this one doesn't work. It's not working for me. But fortunately, we don't need it for this exercise. And the demo gods have fired an arrow at me, and they shot the wrong thing. If this doesn't work, I don't care. If you run on your local system, it should work for you. I tried it about 3 hours ago. It was working fine for me. It should be giving you, when I click on this, it should be giving us green text, which is the token that you fat finger into the Kubernetes dashboard. We're going to do this without the dashboard. It's okay. All right. So, haha, demo gods. Don't laugh too loud, though. All right. So the first thing we're going to do on this cluster is I want to install a container registry. The reason I want to have a registry up and running is I want you to see the experience of how slow it and how fast our container takes to upload and download from a registry. So what we're going to do is I'm going to install a Kubernetes registry, which is just the basic stable Docker registry. And I know what my problem is. I actually have a bad instance. If you notice, my Helm version is version 2, and when this Katacoda started up, it's running a bad instance of Katacoda. So it's not a big deal, folks. All I have to do is restart this scenario, and that explains where the arrow of the demo god landed. It landed squarely on the fact that it didn't start up the cluster correctly. It started it with an old version of Helm. Here's the new version. Now, if I go to version Helm, it shows me version 3. And if I go to token, it shows me the green text. And we've avoided that one. So I'm going to close that other scenario. We're good to go. Okay. So right now, I have to go back to that. I'm going to install that registry one more time. And this time I won't get an error. It's going to install the Kubernetes registry for us. And again, this talk is about just Java inside of containers, but I just want you to experience running these containers on Kubernetes and with the container registry. So I'm just going to expose the registry as a service, and I'm going to get the URL to that registry, and then I'm just going to ask Kubernetes, is it available? There's one there. So yes, the registry is up and running. And in fact, if I curl it, I get the JSON back saying, yes, there it is. I have an empty registry. The next step, we're simply going to just add a little eye candy to it. So I'm going to install a UI container that will connect to that registry, so that when we click on this URL, we will see a UI that represents the same thing that the JSON we're representing. So instead of curling it, I can go to a UI for it. Not a big deal. I just wanted to show you some of the aspects of Kubernetes and how it works if you haven't used it. So the next step, now it gets interesting. So now we're in our Java application. So I have up here under GitHub, under Java Joan, I have an application called Lister. And all Lister does is it runs in the current directory, and it iterates through the current directory and gathers up all the files and the sizes of all those files there. So it's a pretty brain dead type of application. In fact, you can look at the code right here. Lister, here's the main application, has a main method inside of it, and it just iterates through files, and it does a walk, and it gathers the size, and it just outputs to the console using Sprint system out what it found of all the size of all the files. So not a lot of Spring Boot, annotation code in here. It's a very lightweight piece of code. Just want to have some code that runs a little hello world. Here's the typical tree. This is the source code. It uses Gradle, not Maven. Doesn't matter. And there is I have a couple Docker files that we're going to be utilizing to compile it with different ways. We're going to do it with just a straightforward jar file. We're going to use JLink. We're going to use Knative. I was experimenting with Quarkus. I'm not going to do that. Then we're going to put it in Alpine, multi-stage, and then so we have a different couple containers that can be built as we move along. The first one is just going to be a straightforward. The first thing we're going to do is we're going to just simply build the application. Familiar with this? Gradle W, run, and we're just going to build it and run it. Build the jar file and run it. Did it run? It's almost there. This has nothing to do with containers. We're not building any container or anything like that. We're putting the jar file in a container. We're just running the Java executable jar file, and voila. There's Lister. It walked the path of dot, meaning here, and it found that there's 54 files here and these number of bytes. And it happened in 83 milliseconds. And in fact, if we want, there are the, let's see. And then this next task is just to build the jar file. There's our jar file. And in fact, if we just do a time on the Java executable, we get little Linux showing us that in 200 milliseconds, we were able to run that application. So the application itself took about 97 milliseconds, and then the startup time consumed the other 100 plus milliseconds. All right. So there you have an executable jar file up and running, and voila, whoop-de-doo. We don't know how to do that. So now let's put it inside of a container. This is the drop the mic brute force big fat container. In fact, this is what the Dockerfile looks like. 3 lines of code. The first one is I'm just going to take an existing JRE that's in a Debian Slim package, Debian Slim operating system. I'm going to add the JRE. I'm going to use the JRE from that OpenJDK J8. I'm using latest, and I'm going to take my executable jar file, load it into the container, and then I'm going to say Java jar run my application. And there's no port because it's not a microservice. I'm not making any socket connection to this thing. Okay. So the thing you do is you just say if you haven't done it before, you just take this Docker file and you say Docker build, and you give it a package, a tag name, and then you also or a package name, and you also give it a tag name. So in this case, dash F is the location and name of the Docker file. So instead of just Dockerfile, the dash F says, in my packaging directory, I have a Docker file called this, which is what we just catted. And then I'm going to tag this container called Lister A and call it semantic version 010. So let's just run that. And it should just take a moment to build up these layers. Again, this is just the tar of tars that it's building up. And it's putting JRE inside there, our jar file, and then have the executable command. There's our 3 steps. Voila. We now have, in fact, if we look at Docker images, let's see, there's our image. And how big is it? Okay, this is the big number that we're looking at. It's 184 megabytes. So that container with some version of Debian Linux Slim, plus our Java file, plus our jar file, plus our JRE takes up a grand total of 184 megabytes. Pretty big in terms of containers. It's nice to make that smaller. There's ones that are much bit larger than that, believe me. But even that we can reduce. So the next step, what we're going to do is we're going to take that file, we're going to push it to the registry. And I just want to show you in terms of performance how long that is. Now, the longer this is and the larger your image is, the longer it's going to take to push to your registry and pull from your registry. Therefore, your build pipelines, if you're pushing and building and continuously delivering lots of containers over the course of the day, Joe Beta said that at Google in 2014, 2 billion images were pushed out to production every week. 2 billion containers. So they're in a situation where like they need to be pushing these containers very fast. I would imagine none of us are going to ever be in that position, but the faster your things you can push and pull, the better off you're going to be, and the better off you follow that distillation pattern. So let's just run that container, and lo and behold, it actually takes a lot longer, right? And running your jar file just natively, running it from a container is actually much slower, because not only it has to run the application within the container, it actually has to start the container. So there's more stacks, there's more moving parts that are in play here. So we've actually gone in a negative direction. And that's the negative part of running in containers is you have a little more overhead, but the beauty is that you have a lot more isolation. So as engineering and all, it's a depend factor. It all depends about what you want. By putting it in a container, you have some downsides, but you also have some good sides. But let's work on at least making it slimmer in terms of smaller in size. Not necessarily, this exercise doesn't take us through making sure it runs faster. This is just taking us through the making it smaller. So the first thing I want to do is I don't want to use a slim container using, I think it's Debian. I want to use an Alpine container. So that Dockerfile looks like this. So from JRE, so here I'm going to use the JRE Alpine, and I'm going to take the exact same jar file that I have, and I put that inside of a container. And what we want to see is this container going to be smaller, larger, or the same size as the previous, was 184 megabytes. And usually what I do is I survey the room. Is it going to be smaller, larger, or the same size? And you can chat that in your window if you want. But if we can make a mental guess, hopefully you all guess that, yes, it's going to be smaller. Thank you, Chris. Yes, it's smaller, 184 megabytes. So right by switching the operating system, we stripped out basically 100 megabytes. That's awesome. It's much smaller. The question is, well, okay, is it faster to push? Yes, it should be a lot faster, about 50% faster. On this Katacoda instance, it's always somewhat variant, but that one was faster. And if you run it, does it still run? Well, you know what? The running time is 1.5, 1.8 micros. So we didn't really save anything in terms of execution time. I don't know if that execution time is up here as well. I don't. Losing it. It was around the same time. My point is that we're not really getting a faster execution time, but we are getting a smaller container. How much? Yeah, and we looked at how much smaller it is. So we went from 184 megabytes down to 84 megabytes. But let's do a better job. I believe that we can do a better job. So let's get into multi-stage containers. So remember I said a multi-stage. With multi-stages, you can actually throw out some of those previous stages. So here's our multi-stage Docker container for building Java and then putting that Java jar into a container. So all this does is we're going to actually take Gradle that's running inside this container, Gradle with Java JDK 10, and we're going to copy, we're just going to make sure we're going to copy our content into the container. So in other words, we have local source code right here, and we're going to copy it into the container, and then we're going to run Gradle build. So copy the content, do the build, and then we're going to take. Here's how it works with the multi-stage. Is we're going to do a copy command, and it says from builder because it matches. This right here. See this label, builder? So this is my first from, and it labels it as builder. So it's basically saying from this stage, grab this artifact and put it here and make it and call it lister. So our command is just going to be in our user bin Java directory. I want to run Java, and I just want Java jar. I'm going to run this local dir file. So this stage builds our jar file, and then this stage execute it. When we run it, the only thing that's going to be inside the container is this, and it's not going to have all of Gradle inside of it. Okay, so I'm going to ask you again. I'm going to build this. Is this container going to be smaller, larger, or the same size? Now that we're using multi-stage. Any guesses? Same, right? Jonathan says. Chris also says same size. There seems to be a consensus here. And Kit? All right. Everybody's seeing same size. Because now everybody's like, yeah, everybody says same, saying, I'm going to look smart too. I can say same. Good. Well, let's see. So the premise behind that is like, I think people are saying this is the same size because just like the container before, it's still just a JRE with the jar file with the execution of the executable. They're just with the fact that I'm building it inside the container versus outside. I'm not really throwing anything out. And indeed, you are correct. Because if you look at the images, we went from 184 down to 84. And now with the multi-stage build, we're still at 85 megabytes. So didn't really buy us a lot there. But if we were using Go, Go compiles to binary, and we could throw all that out. So it actually would buy us a little bit. And I'm leading you up to GraalVM, right? So we're going to do GraalVM in a multi-stage, and hopefully, I think you can guess what we're going to do in terms of size. Is this faster to push? Well, it's pretty fast because a lot of the stuff is already cached, so that was pretty fast to do because it's smaller. And does it still execute? It better, but this is just a verification that it still runs. And boy, it's taking a long time right now. Oh, it took 8 seconds to run. All right, there was some hiccups there. I think that's mostly in Kata Coda. This is just doing Docker run, not even using Kubernetes. It's just running Docker. All right, so if we run it hot enough to get it hot, the execution time is roughly the same as the others. So no surprises there. It's the same size, same execution time, still works, but it was an alternate way of doing it. So remember I talked about JLink. JLink is the utility that will strip out all of the modules that we're not using inside of Java. Obviously, it's a lister, little recursive thing. The only thing it's doing is some file I/O. So there's a whole bunch of modules inside of Java, like the SQL and JDBC, that it's not going to need. So let's engage JLink as part of our multi-stage build. Okay. So without going the whole GraalVM native compiler route, you can just do this, and you're gonna win. Let me show you. If you take Java, so here's the first stage, and it takes Java OpenJDK 12. Okay, and I did it with Alpine, and inside there I had JLinker. So all I'm doing is, rather than doing a full build, all I'm doing is I'm saying, yeah, actually I'm doing Gradle W. So I'm copying the code into the container, and then I'm doing a Gradle W jar as one task. And then the other task is, okay, now that I have the jar file, I'm going to run another plugin called JLink, which will run the JLink compiler. You get it? And then that will create in the build directory two things. It'll create our jar file. In fact, right here. Yeah, here's our jar file. So from JLinker, this is our jar file. I want to copy it into the container. And the other thing we're going to do is from the JLinker in the build directory, we're going to take all the files from the directory called quote unquote image directory. That image is our new JRE image that JLink created it for us. Did everybody follow that? Maybe a couple no's or thumbs up or yeses or no's. You understandable? Like that's an important concept. Like you've got good, excellent. Thank you. I follow. All right. Everybody's on board here. Hopefully everybody, I don't know if that's a full consensus of the whole online room here, but it's nice to get that feedback. Thank you. It's hard as a presenter not to get the feedback. I'm like, what's going on here? I'm not getting any feedback, but because I'm used to doing this live. So let's engage in this. The only one thing we need to do is I need to move a file in there that allows our source code to be Java 9 Jigsaw multi-module compliant. And we just need to add a blank file in there called moduleinfo.java. So I'm just going to copy that in there, and then I'm going to engage this Docker build. So survey again. Is this container, now that we're doing JLink, going to be larger, smaller, or the same size as our previous one? Smaller, smaller, smaller. Okay, consensus is smaller. You all smart here. Good. Is it going to be, how much smaller? Let's take a guess at how much smaller. I just scrolled up because the answer was there. 50 megabytes, 25%. Ooh, some people are going percentages. Okay. 5 times smaller. Okay. 20 megabytes, 10 times perhaps. We'll see. Thank you for all your answers. That's awesome. All right. The answer is, so we went from 184 down to 84. We did the multi-stage with 84. Now we're doing multi-stage with JLink, and we got down, what's the calculation? About 40 megabytes. Okay, so anybody who guessed around that, good job guessing. But it was a guess in that sense, because if you haven't used JLink before, it's kind of a mystery. But you get the idea. It's another tool that you can apply for this distillation pattern. And it's a good thing to show your colleagues about how to run Java in a container. Again, before you go down the whole Quarkus, Helidon, Micronaut route and get into GraalVM, you can just apply this and do this with Alpine, with Java 14. And out of the gate, you're going to have a much more efficient, faster running container. Faster running, that's debatable, but it is going to be a much smaller container. So let's inspect the container. The other thing you can do is we can actually go into the container. So this is going to do a Docker run. I'm going to get into the shell. So notice our prompt just changed. And if I do an ls within the container, there indeed is our JRE that we just built. And there's our jar file. It's actually, the JRE is in a special directory where the Java is. Where do we copy to? The Docker file copied it to, I'm just going up to the copy, where to copy? It copied the JRE to Java minimal, which is opt JRE. So if I do an ls, where I am right now, I'm just the root. So if I do ls opt JRE, there indeed is our directory tree. Tree is in here. Tree's not there now. So there's our directory tree. That is the JRE that was built by JLink. That's in this container. Okay. We're on the last step, by the way, folks. We're wrapping this up very quickly. I know it's been a long session, but this is the aha moment, I hope. So let's look at this Dockerfile multi-state. Hey, what's going on here? No, what's going on? Multi-stage Dockerfile. Oh yeah, thank you. I do this all the time. I'm inside the container. There's no Docker files in there. I need to exit out. And if you do this, by the way, don't exit twice because you'll lose the Katacoda instance, because you'll exit out of that. So if I do, thank you, everybody, debugging on the fly. So there's a cat of our multi-stage. The first stage does, look at this, run GNU install. So I just take a GraalVM image, and then I install inside of it the native image compiler. And then I run native image, and I say, oh, by the way, I have a jar file here, and this is the jar file. So I'm just copying the jar file in. And then, so what that does, it does more than just JLink. It's doing JLink. It does all the modularization, and it creates a new binary. And we do this from builder. We copy that into this directory. So from the app directory lister, which is being generated by native image, we copy this binary in. The key thing is look at the from command. This is from this Alpine container. Okay, now I'm cheating here, and I need to change this Katacoda scenario. What I did is I had a problem with this version because so GraalVM is using Debian, which is using GNU-C, glibc. So this binary is compiled with glibc. And I was like, well, I want to run the glibc in a binary, Alpine binary. And it turns out that this fellow or person, gal, I don't know who wrote this, created an Alpine image that has not only libc inside of it, but also has muslc inside of it, but it also has libc, and it's compliant and it works together, if you get it, what I mean. So basically you can run something that's compiled for glibc, which is larger, and it works in Alpine because this Alpine has glibc inside of it as well as mucilc. Do you get it? So it's a little bit of a hack there. And I could do more in terms of squeezing the water out of the stone. But I think hopefully you'll be impressed that even with this, I'm squeezing a lot of water out of it. So let's do a Docker build. Did everybody follow that? It was a little confusing because you get down in the weeds of like libcs and GNU-C and mucilc and Linux and how that works. But the idea is really what I couldn't find was an Oracle GraalVM that was that had a base container based on Alpine with mucilc. So I was forced to build for now a binary compatible that was for glibc. Now, it's going to take a lot longer to build. So we've traded off a pipeline build because not only has to build all the Java, but it actually has to compile the binary image, which linkers take a long time sometimes, especially the complicated one, the JRE ecosystem. And then it has to build the container itself. So you got lots of things going on there. We've traded slowness of the pipeline with the speed of runtime and the efficiency of the container size. So we're following the distillation pattern, but we've got a hit on the pipeline side. Now, hopefully, the native image is an early version, and they're going to be making that more and more efficient as time goes on. How much more efficient can they make it? We'll see. But that efficiency is related to our CI/CD pipeline build time. And I'm chatting on here because I'm not getting feedback from the audience, and I'm waiting for a build. So we're all watching grass grow here, and hopefully I can chat long enough. So any questions so far? You're getting to the native. That's something new for me. Cool. It's new for me too. I have a colleague, Brian Sletton. He does a lot of talks about machine learning, and he's very opinionated about WebAssembly. So that's a whole nother route to go down in terms of the containers as well, following the distillation pattern. So I don't know if I'd made WebAssembly before. That's a good trade-off, assuming it's better performance. Well, remember that slide that we had? I'll see if I can take you back to that slide on GraalVM. Oh boy, I forget where my slide was for GraalVM. I forget where it is. Sorry about that. Remember that slide I had for? Well, actually, what I could do, I can take you. Oh, look, it's built already. All right. Well, I don't want to. I'll take you to that chart in a second, but it's just built. So, okay. Sorry again. Is it going to be smaller, larger, the same size? I think everybody knows it's going to be. I won't wait too long. Smaller. Thank you, Bruce. Cool. All right. So it's smaller. By how much? We went from 184 megabytes in this talk down to 25 megabytes. That's a savings of about, it's a lot. I'm not going to do the math on it. But this basically is saying the Java application linked to the binary form is only about 8.5 megabytes. So we took a very large application running with a fat JRE and slimmed it down with modular, and then we slimmed it down with compiling native. The question is, well, does it still run? And indeed, I just ran it. What happened? Oh, I'm sorry. I just did a shell into it, and if you look here, it just has one artifact inside of the operating system. And if you looked at, was it op JRE? There is none. There's no JRE in here. Okay, it's just our native compile. This is not a jar file. This is the binary compile image. So if we run it, sorry, there's a run command right there. There's a run command. It's much faster to run. Now again, it's still in the container, but the startup time it's much quicker. And I don't know if you noticed when we originally ran our original Java command. Yeah, I don't remember where. I'm not going to run it right now. When we originally ran it, it was about that speed natively. Now that we put everything in a container, it's about the same speed, even though it's running inside of a container. So the size of it is smaller, and the runtime is a lot faster. And by the way, when you run it, the memory footprint is going to be much smaller. All going back to Graal. Oh, by the way, here's the registry with all of our containers inside of it. Here's our little eye candy of the different containers. If you would go to GraalVM website, main landing page, that slide I had of the, hopefully they didn't take it off. Did they take it off? Oh no, they took it off. I forget where it is. Why GraalVM? Might be there. Darn it. They had charts. Oh, there they are. Okay, you see? That's the performance we're getting out of running in a container. So that's kind of the that's it, right? So voila, drum roll. We did the big finale. That's the end of the scenario. I would encourage you to run this yourself, show it to your friends, and then send me feedback. I'd love to know like how you did on it and did other people get it. How do you adjust the memory and heap size on the binary? There are compilation commands for that of GraalVM. GraalVM has all these command line parameters for that as well as, and then you run the container, and then you have to tell Kubernetes how much CPU and memory you're going to use as well. There's two different settings. I would encourage you to look at those scenarios, and there's many other scenarios you can look at. And I'm just going to come back to the slides. We did the hands-on, and I just wanted to wrap it up with a thank you. There is those are the more categorical. If you want to learn about Quarkus, I showed you where you can learn about that at Red Hat. You can also learn about Micronaut and their documentation. And yeah, thank you, Ted. Good calculation. Final version about 13% of the first image, 13.5% total of the image. Additional reads, you'll learn more about JLink, multi-stage, Alpine, Portala. You can learn about all these things I threw at you in this whole 2.5 hours or so of talking. And I just want to let you know you've learned a lot in this session. Maybe Bruce, what I'll do is I'll turn the our presentation back on, and I'll add you back in if you're there, or you can turn on your microphone, turn on your camera.
Can you hear me now?
Yes, I can. What do you think? No, I can't ask everybody. I can ask you.
Okay. Oh, I thought it was a great presentation. I've been actually looking for someone who could give a Graal presentation because it's a pretty exciting technology. When I was at DevNexus, I talked to Oleg, but he's in Estonia, and getting him to St. Louis may be hard. But you mentioned one of your No Fluff Just Stuff colleagues. So we may talk offline and see if we could bring him in if we can't get Oleg.
Yeah, that's Daniel Hosa. He lives in New Mexico, so I don't know how to get him to St. Louis.
Yeah, I don't know.
Something online just like this, I bet. And he does one talk called Graal the Magnificent. And Michael Carducci does a talk on Micronaut and running that as well. Mine is, and then another guy, Raju Gandhi, he does a great talk on Docker and how to put things in containers. So distillation, and follows the distillation pattern as well. So yeah. Yep.
Okay. So are there any questions for Jonathan?
Thanks so much. Oh, thanks everybody. You guys are awesome. My apologies. I keep saying guys. I'm from the Connecticut Northeast. I need to stop doing that as a habit. New York and me coming out.
Okay. So sounds like they must have all got it. I mean, they're there. At least we think they are, and they are responding. We just don't have very many questions. I guess 100% of everything you said must have
Awesome.
sunk in.
Good. We have this recorded. That's good. So if you don't want to go back, I guess, Bruce, you're going to be posting it somewhere recorded. I'll also just email you the slides. So you can
yes, if you could email me the slides. Now, do you have a website of your own where you post your slides?
No, because most of the stuff I do through No Fluff, Just Stuff. So that's all part of the conference series and symposiums. But when I do one like this for the Jug, I'll post up my slides for the one I give a talk on. But I haven't just posted up all of my slides yet. I'm still working on that.
Okay.
What I want to do.
Yeah, if you could email me your slides. We're a little behind as far as getting everything posted in our knowledge base, but we'll eventually get it caught up here. And then also, if you could send me the link to the recording, and we'll have the slides and the recording for everyone to watch.
Slides and recording would be great. Yep. And I find most people are like they haven't either. They've heard about it. They've heard about JLink. They heard about JDeps. A lot of people haven't heard about Graal yet. Like, what's this? No, Micronaut stuff, and and a lot of people are just like Docker, Spring Boot, and I'm going to run it.
Right.
This is the idea about expanding those horizons. So I think everybody gets it.
Yeah, we have had presentations on Micronaut. I mean, OCI is our sponsor, and so Jeff Brown came in and did a presentation on it. Yep, we're getting it direct from the source.
That's great.
When it comes to Micronaut, since St. Louis is the home of Micronaut at OCI. So we've been able to do that. But I am working on trying to see if I can get a Graal presentation here at some point. So I may be touching base with you if I can't get Oleg to fly in all the way from Estonia. That may be hard.
Okay.
All right. So for folks that are still watching, I just want to say, I'm sorry. I just wanted to announce.
I just want to say, somebody, I just saw a question go by. Love to have you come back. I would love to come back, Bruce, if you want to invite me, and I have more talk.
Okay. All right. Yes, I have your email, and we'll keep in touch. For those who are still watching, I just want to remind people we're working through unprecedented times here with all this virus and everything, so we don't know exactly how we'll do the next meeting. But I have been in touch with the presenter. We're going to try to see if we can do it online as well. So the bottom line is just watch meetup.com/gatewayjug, and you'll see the announcements if we end up moving it online or having to make a schedule adjustment for these trying times. So
all right, and if
that's really all I wanted to say, was to just remind people to watch the website.
And if anybody wants to see other talks from the other speakers outside of the Jugs, again, the No Fluff Just Stuff conference series is now online, and we're doing 3-hour workshops in the morning.
Right. Now, we normally are in touch with Chase Zimmerman, and we would have raffled a No Fluff Just Stuff ticket.
Yes.
But since the presentation, since it was rescheduled for St. Louis to, I think, the fall, what we'll do is we'll raffle that ticket. I mean, if they're having the conference again, presumably we'll be back to normal, and we'll just raffle that ticket right before the conference.
Yeah, we'll be back in the fall. That's the plan, if everything works out. Okay.
All right.
I hope to see everybody there.
All right. Yes, and say hi when you're back in St. Louis here when things are back to normal.
Yeah.
Okay, I appreciate it.
Good luck, everybody, in these trying times.
Thank you, everybody. Thank you for coming. And just watch the site, and we'll see if we can do this again here next month. Thanks a lot. Bye.